All right, guys. Yeah. Did you try any of the problems? I mean, the first question is from the textbook. E1 says a traveler covers a distance of 413 miles in a time of 7 hours. What is the average speed? You may use this. I mean, this is the same kind of question as your reference. Okay. So you can solve this. So a traveler covers a distance of 460 miles in a time of 8 hours. What is the average speed of the trip? Now it's just fine. Problem is asking for average velocity. So this is from the textbook. You're asking for. So you have in the textbook it's E1. If you have the textbook, as I said, you can have an older edition of the textbook. It's only a matter of changing some of those things. And you can have the ebook version of the textbook as well. An older edition should be really pretty straightforward. But what I said is have a textbook, have some version of the textbook. Okay. So then what are my given parameters? So you go ahead and then when you read it, the distance is given, which is 460. Is it miles or kilometers? Miles. Okay. So we usually have miles as mi. In how much time? Time is in 8 hours. Okay. Then what are you required? What you are required in this problem is the average speed. Okay. Then how much is the average speed for this trip? So then when you come to the solution, the main part of the solution is finding the right equation, which is d over t, okay, distance over time. Because we're finding average speed, then your d is 460. Divide that by 8 hours miles. Okay. So therefore, it's going to be, yeah, very good, 57.5 mile. To differentiate mile from meter, I use mi for mile. Okay. So this is what the answer is. All right. Okay. So it's pretty straightforward. Okay. Then E2 in the text. E2 in the text states like a walker covers a distance of 2.4 kilometer in a time of 30 minutes. Then what is the average speed? So E2, what are my given parameters again? Until you well versed the whole idea of solving physics problems, I encourage you to follow those simple steps. Given, required, solution. Given, required, solution. What am I given? What am I required to find? And then what is the solution? Okay. So because it just helps you just to it's always write it out. That's the only way. It helps you to not to go back and forth in the problem or in the textbook. Okay. So the question says there is a distance. How do you know that's distance? It says the person covered this much distance. So it says like distance is equal to 2.4 kilometers. And then there is time, which is 30 minutes. And then what you are required is to find the average speed. That's again going to be represented by S, the average speed of the trip. So when you come to the solution, okay, so S is distance over time, okay. Then what you have, S is how much is your distance. So, and it's asking you like what is it in kilometer per hour. Okay, so since you are asked in kilometer per hour, then you need to, because the time is not given in terms of hours, it's given in terms of minutes, right? So therefore you need to convert this 30 minutes into its equivalent to hour. Okay, how do you do it? So you follow the same procedure, like you have 60 minutes, and then in every minute you need to eliminate the minute part and replace it by hour. In every hour you have 60 minutes, right? So therefore you cancel out the minute and then you leave the hour. So 30 divided by 60 is 0.5, or half an hour, right? 30 minutes is half an hour. So your distance, which is 2.4 kilometer, divide that by 0.5 hours. Excellent, very good. So what you will have is like 4.8, right? Kilometer per hour. Okay, very neat. So most of the equation, most of the problems that we solve in this class, as you can see, is like you identify what is given in the problem, you pick the right formula, and then you plug those things in. That's how pretty much yeah, what we do pretty much throughout the semester. Okay, so any question? Then E4. So for now, they say yes. Because the textbook specifically asks you how much is in kilometer per hour. Okay. If the textbook or if the problem doesn't state anything about the unit, then you can go ahead and then find it at the way it is given. So E4 from the textbook, I'm going to read it for you. A driver drives. So again, listing out the given, the required in the problem helps you not to go back and forth in the textbook, like to to identify what is given, what is required, what's given, what is required. So I'll be listing it out while I'm reading. A driver drives for 2.5 hours. That 2.5 hours is associated with 2.5 hours is associated with time, right? At an average of 60 miles per hour. So we see that, like, if it says miles per hour, then I know that that is speed, because the unit of speed is miles per hour, kilometers per hour, meter per second. This is a simple kind of unit conversion and multiplication of the formulas and all that, right? But we usually use SI units. Okay. So what is required and what makes this problem a little different? So now you are required distance, unlike the previous two examples where distance was given and time was given to find speed. But now time is given, speed is given, now you are required to find distance. So, but the procedure is pretty much the same thing. what you will do is start from the formula that you know. What we know is speed is equal to distance over time. That's what you know. But in this time, what you are asked to find is not the speed. You are asked to find this guy, the distance. So therefore, you need to isolate it from the equation. That d, distance, has to be by itself. But in this particular case, distance has time with it. So what do? Then what you will want to do is, of course, you will want to eliminate the time and make this guy free from time. What do that? You multiply it by t. So that it's gonna go away. If you multiply the right hand side of an equation, any mathematical equation, by t, then you must do the same thing on the other side. Okay, so there is that, like, t cancels out with t, then you have d. So therefore d is equivalent to s times t, or t times s. Okay, you know, like when you study, I encourage you like to write and list all the formulas that you need or that you learned in general. I'll put it that way. That's gonna be like your cheat sheet, like for your exams or something. Because like, even though classes are remotely held and like, instead of trying to find where the formula is in the textbook or in your notebook, what I encourage you is like, just get a clean paper, clean page, and then from there list all the formula that we are where that's gonna be like your formula cheat sheet for you. You can use it like during exams, like you will know where to find the formulas right away, instead of trying to find, oh, where is it, chapter 1. Otherwise you will just literally spend all your time trying to find where the formula is in your notebook. Okay, so then now I have a new formula to find distance, but all my given parameters are known. Then it's just a matter of substitution. S is 68 miles per hour multiplied by 2.5 hours. Then hour cancels out with hour. Then multiply that 68 miles by 2.5. Then the answer is going to be 170 miles. Okay, nice, clean. All right. Then now E15, I think E15 is something that probably we need to solve it after learning another physical quantity known as acceleration. Okay, so acceleration. What is acceleration? Why do we need like acceleration? Why do we need to know about acceleration? Acceleration is like when you are slowing down, you have acceleration. When you are speeding up, you have acceleration. If you're not speeding up or slowing down, you don't have any acceleration. So it's like the change in, like, at the definition given here, it's like the change in velocity. So you need to have a velocity change. The change in velocity over time. If the change in velocity over time. Okay, changing velocity means an acceleration is present. So in general, it means acceleration is the rate of change of velocity. How fast the velocity is changing. So this delta Greek letter delta that you see here, it means change, nothing else. Okay, don't get frustrated when you see a new symbol like that you haven't seen before. It doesn't mean anything. It means change. That means change means what was at the beginning. I mean, what was at the beginning, you know, deducted from what you have at the end. So it's like this. So consider a car is moving at 20 meters per hour per second, or 10 meters per second, like 10 meters per second here, and then after 2 seconds it is still 10 meters per second. After 3 seconds it's 10 meters per second. This guy has no acceleration. Acceleration is it's a change. In the three seconds it's the same velocity, the same in the same direction, the same velocity. Therefore, this guy doesn't have any acceleration. There's no acceleration. To have acceleration, you need to have a change. What do I mean by that? Let's say this one, on the other hand, probably need to use a different color. It started with 0. After 1 second, his velocity was 10. After 2 seconds, its velocity was 20. It means it's increasing. After the 3rd second, its velocity is 30. You know, I'm just putting them proportional to the size or the magnitude of what you have. You see? In this particular case, you can see that like the velocity is increasing. That means there is a change in velocity. Then acceleration is not 0. How about the other way around? What if like you start at a bigger value and then start to slow down? And on the other hand, you're starting at 0 time, you have your velocity was 30 meters per second. And then after 1 second, yours is 20. After the 3rd second, yours is 10. And then after the 4th second, maybe yours is 0. You're slowing down. Again, acceleration is not 0. Is not equal to 0. There is acceleration. If a car is moving like in a very fantastic road, smooth, without changing its velocity, that means it's changing its direction and in a straight line at a constant speed or velocity, its acceleration is 0. Okay, then what is the SI unit of acceleration? The SI unit of acceleration will be the SI unit of velocity, which is meters per second, same way as speed, right? Divided by the SI unit of time, which is second. So therefore, meter per second per second. That meter per second is the same as meter per second squared. All right, meter. So yeah, here it is. Okay. So therefore, when I ask you like what is the SI unit of acceleration, it's meter per second squared. It has varieties in a metric system. Other varieties like centimeter per second squared, millimeter per second squared, kilometer per hour squared, feet per second squared in the US customary, all those. But in SI unit, that's meter per second squared. Okay. So we will also talk about like, you know, the average acceleration, we don't talk a lot about like okay, so for now we're going to assume like you know, sometimes you can have a negative acceleration. Okay, a negative acceleration. So it's a vector like velocity. It can be positive or it can be negative. But keep in mind it can either be positive because it's a vector quantity. It can be negative too. So therefore, acceleration represented by small letter, it's vector. What else? The velocity is vector. Whereas speed, scalar. This is just more or less a revision for you. Alright, guys? Alright? So, most of the time, like, at least for this one, just to keep it simple, if you have the car slowing down, right? Because we're assuming all the motions are... So, the car slowing down in the positive x direction or to the right. So if the car is moving and if it's slowing down, and if the motion is like this in this direction, and if the car is slowing down, then you will end up with a negative acceleration. Your acceleration is going to be less than 0. Okay, but for now let's limit it to that. Negative acceleration doesn't always mean that the car is slowing down. Okay, maybe speeding up. So having said that, like I don't know if you have the textbook with you, that's good. If not, there's an example, example 2-3 from the textbook, and I'm going to write the given parameters for you. What it says is the driver of a car steps on the brakes. That means it's going to start to slow. So, so you will have your given parameters. It says that like the velocity drops from. That means there was an initial velocity. Initial velocity. The textbook uses 0, v0, which is initial, which means original. Originally, its velocity was 30. And it says a unit is given as meter per second. And then it says its speed dropped from that value to a final value of 10 meters per second. In how much time? It says in 4 seconds. So time is given as well. And then it says like what is, so your required parameter, you are asked to find how much is the acceleration of the vehicle. Then when you come to your solution, always it's all about picking the right formula. So in this particular case, acceleration. And we know that the formula for acceleration is final velocity minus initial velocity divided by how much time was elapsed during that period. So there is that, like, you know, everything is pretty much given. Your final velocity, the car slowed down, then it's 10. Everything is in SI units. You don't need to carry out any unit conversion because meter per second is perfect for velocity. Seconds is perfect for time. Okay. So therefore it is like 10 minus 30 divided by 4. Here is seconds. Here the units are meter per second. So 10 minus 30 is negative 20 meter per second. You divide that by 4 seconds, then your acceleration is going to be negative 5 meter per second per second. Okay, so this is the rate at which the speed is changing. This is the speed at which the speed is changing. Okay, so that negative interpretation, it means like, you know, the textbook literally says like, oh, the car was moving in the east and its velocity changed in the east. Okay, but you know what a negative acceleration means? So if the car is moving in the east direction, this is like the motion of the car. A negative acceleration means it's actually, the car is moving in the east, but its acceleration is actually in the west. That's what it means. So that negative sign just tells you you are moving in the east direction, but your acceleration is in the west direction. Why that is happening? Because you're moving to the right, you're slowing down. In other words, means your direction of acceleration is in the opposite direction. So that means that negative, the interpretation of the negative, because the answer for this question, 5 meters per second squared, the physical interpretation would have been the car was speeding up in the east direction. But whereas now, since this acceleration is 5 meters per second squared and it was negative, then it means the car was moving in the east direction, but its acceleration is in the west direction. So this is west. Okay, so you know, if you give me both answers are acceptable for me. Negative 5 meters per second squared, you leave it like that, fine. You give it to me like 5 meters per second squared moving in the opposite direction, because it literally says the car moved in the west direction, I mean in the east direction. Okay, so that's what is happening in general. All right. So, do you have any question? Otherwise, I'm going to give you some time just to ask me anything about your lab in the next 10 minutes or something. Those are a few formulas that we will be using. Like in the next class, probably I will use this, and I will use this, and I will use this to to solve some acceleration problems. Like for instance, in the previous two topics, like what we were saying was speed was equal to just randomly distance over time. And we did an example that we came up with distance is equal to speed times time. Keep in mind, this only works when we have average velocity, average speed, right? Average, that was for the average speed. Okay, and the other average speed was given. But what if, like as in the previous example, you had two velocities, one velocity and the other velocity. So which velocity are you going to use? If I ask you to find the distance, then definitely you are going to take the average of the two velocities. So as a result, like you will be involved with finding in this equation, okay, and so on and so forth. So I'll come to explain those ones, and also like what if you have an initial velocity and acceleration is given and time is given, and what if you are asked to find the final velocity? How do you do it? So this is the formula. So those are already done for you. You may wonder, like, how did you come up with this formula? I mean, it's not really that hard. The textbook also explains it, how like what if the acceleration, when acceleration is involved, like you may probably need to find final velocity. It doesn't end like questions only what is the speed if distance and time are given, or what is the distance if speed and time are given. You may have variation of questions like what is the final velocity, or if the initial velocity and the acceleration and the time are given. So having said that, what I encourage you to do is, like, you know, if you get the textbook, as I said, PDF format, ebook, whatever format you may have, it doesn't matter, because pretty much the problems are very aligned and the same. I would say they're pretty much the same thing, except that, like, one edition has a different number from the other one. Okay.